Hello guys, welcome back to my channel. So in today's video, I'll be sharing about AWS Solution Architect Associate practice exam questions. So I have created a series for part 1, 2 and 3, so you can go back and watch those videos as well. I'll leave the link in the description box and you can check those questions so that you can get an idea what we have learned till now and what all questions has been discussed till now. So without any further ado, let's get started. And one more request, please subscribe to my channel. Now let's look into question number 51. It says a company is developing an application that provides order shipping statistics for retrieval by a REST API. The company wants to extract the shipping statistics, organize the data into an easy to read HTML format, and send the report to several email addresses at the same time every morning. Which combination of steps should a solution architect take to meet these requirements? Choose two options. And the options are A. Configure the application to send the data to Amazon Kinesis Data Firehouse. B. Use Amazon Simple Email Service to format the data and to send the report by email. Create an Amazon Event Bridge, Amazon CloudWatch events, scheduled event that invokes an AWS Glue job to query the application's API for the data. Option D, create an Amazon Event Bridge, Amazon CloudWatch event, scheduled event that invokes an AWS Lambda function to the application's API for the data. And option E, it says store the application data in Amazon S3, create an Amazon simple notification service topic as an S3 event destination to send the report by email. And then let's look into the correct option. And the correct options are B and D, which says that you have to create a simple email service to format the data and to send the report by email. And D option, it says that create an Amazon event bridge, Amazon CloudWatch event, scheduled event that invokes an AWS Lambda function to query the application's API for the data. Now let's look into the next question. Question number 52. A company wants to migrate its on premises application to AWS. The application produces output files that vary in size from tens of gigabytes to hundreds of terabytes. The application data must be stored in a standard file system structure. The company wants a solution that scales automatically, is highly available, that requires minimum operational overhead. Which solution will meet these requirements? And the options are A. Migrate the application to run as containers on Amazon Elastic Container Service. Use S3 for storage. Option B. Migrate the application to run as containers on Amazon Elastic Kubernetes Service. Use Amazon Elastic Block Store for storage. Option C. Migrate the application to Amazon EC2 instances in a multi-AZ auto-scaling group. Use Amazon Elastic File System to host storage. Option D. Migrate the application to Amazon EC2 instances in a multi-AZ auto-scaling group. Use Amazon Elastic Block Store for storage. Now let's look into the correct option. And the correct option is C. Migrate the application to Amazon EC2 instances in a multi-AZ auto-scaling group. Use Amazon Elastic File System for storage. Now let's look into the next question. Question number 53. Company needs to store its accounting records in Amazon S3. The records must be immediately accessible for 1 year and then must be archived for an additional 9 years. No one at the company, including administrative users and root users, can be able to delete the record during the entire 10-year period. The records must be stored with maximum resiliency. Which solution will meet these requirements? And the options are A. Store the records in S3 Glacier for the entire 10-year period. Use an access control policy to deny deletion of the records for a period of 10 years. Option B. Store the records by using S3 Intelligent Tiering. Use an Amazon use an IAM policy to deny deletion of the records. After 10 years, change the IAM policy to allow deletion. Option C. Use an S3 lifecycle policy to transition the records from S3 standard to S3 Deep Glacier archive. After 1 year, use S3 object lock in compliance mode for a period of 10 years. Option D. Use an S3 lifecycle policy to transition the records from S3 standard to S3 one zone infrequent access. S3 one zone infrequent access after 1 year. Use S3 object lock in governance mode for a period of 10 years. And the correct option is C. Use an S3 lifecycle policy to transition the records from S3 standard to S3 Glacier Deep Archive after 1 year. Use S3 object lock in compliance mode for a period of 10 years. Now let's look into the next question. Question number 54. And the question says a company runs multiple Windows workloads on AWS. The company's employees use Windows file shares that are hosted on two Amazon EC2 instances. The file shares synchronize data between themselves and maintain duplicate copies. The company wants a highly available and durable storage solution that preserves how users currently access the files. What should a solutions architect do to meet these requirements? And the options are A. Migrate all the data to Amazon S3, set up IAM authentication for users to access files. Option B. Set up an Amazon S3 file gateway, mount the S3 file gateway on the existing EC2 instances. Option C. Extend the file share environment to Amazon FSx for Windows file server with a multi AZ configuration. Migrate all the data to FSx for Windows file server. Option D. Extend the file share environment to Amazon Elastic File System with a multi-AZ configuration. Migrate all the data to Amazon S3. Now let's to Amazon EFS. Now let's look into the correct option, and the correct option is C. Extend the file share environment to Amazon FSx for Windows file server with a multi-AZ configuration. Migrate all the data to FSx for Windows file server. Now let's look into the next question, question number 55. A solution architect is developing a VPC architecture that includes multiple subnets. The architecture will host applications that use Amazon EC2 instances and Amazon RDS DB instances. The architecture consists of six subnets in two availability zones. Each availability zone includes a public subnet, a private subnet, and a dedicated subnet for databases. Only EC2 instances that run in the private subnets can have access to the RDS databases. Which solution will meet these requirements? And the options are A. Create a new route table that excludes the route to the public subnet CIDR blocks. Associate the route table with the database subnets. Option B. Create a security group that denies inbound traffic from the security group that is assigned to instances in the public subnets. Attach the security group to the DB instances. Option C. Create a security group that allows inbound traffic from the security group that is assigned to instances in the private subnets. Attach the security group to the DB instances. Option D. Create a new peering connection between the public subnets and the private subnets. Create a different peering connection between the private subnets and the database subnets. And the correct option is C. Create a security group that allows inbound traffic from the security group that is assigned to instances in the private subnet. Attach the security group to the DB instances. Now let's look into the next question, that is question number 56. The company has registered its domain name with Amazon Route 53. The company uses Amazon API Gateway in the CA Central 1 region as a public interface for its backend microservices APIs. The third party consume the APIs securely. The company wants to design its API gateway URL with the company's domain name and corresponding certificate so that the third party services can use HTTPS. Which solution will meet these requirements? And the options are A. Create stage variables in API gateway with name is equal to endpoint URL and value is equal to company domain name to override the default URL. Import the public certificate associated with the company's domain name into AWS Certificate Manager. Option B. Create Route 53 DNS records with the company's domain name. Point the alias record to the regional API gateway stage endpoint. Import the public certificate associated with the company's domain name into AWS Certificate Manager in the US East 1 region. Option C. Create a regional API gateway endpoint. Associate the API gateway endpoint with the company's domain name. Import the public certificate associated with the company's domain name into AWS Certificate Manager in the same region. Attach the certificate to the API gateway endpoint. Configure Route 53 to route traffic to the API gateway endpoint. Option D. Create a regional API gateway endpoint. Associate the API gateway endpoint with the company's domain name. Import the public certificate associated with the company's domain name into AWS Certificate Manager in the US East 1 region. Attach the certificate to the API gateway APIs. Create Route 53 DNS records with the company's domain name. Point an A record to the company's domain name. And the correct option is option C, which says create a regional API gateway endpoint, associate the API gateway endpoint with the company's domain name, import the public certificate associated with the company's domain name into AWS Certificate Manager in the same region, attach the certificate to the API gateway endpoint, configure Route 53 to route traffic to the API gateway endpoint. Now let's look into the next question. Question number 57. A company is running a popular social media website. The company gives users the ability to upload images to share with other users. The company wants to make sure that the images do not contain inappropriate content. The company needs a solution that minimizes development effort. What should a solution architect do to meet these requirements? And the options are: A. Use Amazon Comprehend to detect inappropriate content. Use human review for low confidence predictions. Use Amazon recognition to detect inappropriate content. Use human review for low confidence predictions. Option C. Use Amazon SageMaker to detect inappropriate content. Use ground truth to label low confidence predictions. Option D. Use AWS Fargate to deploy a custom machine learning model to detect inappropriate content. Use ground truth to label low confidence predictions. And the correct option is option B, which says use Amazon recognition to detect inappropriate content. Use human review for low confidence predictions. Now let's move on to next question. Question number 58. A company wants to run its critical application in containers to meet requirements for scalability and availability. The company prefers to focus on maintenance of the critical applications. The company does not want to be responsible for provisioning and managing the underlying infrastructure that runs the containerized workload. What should a solution architect do to meet these requirements? And the options are: A. Use Amazon EC2 instances and install Docker on the instances. Option B. Use Amazon Elastic Container Service on Amazon EC2 worker nodes. Option C. Use Amazon Elastic Container Service on AWS Fargate. Option D. Use Amazon EC2 instances from an Amazon Elastic Container Service. Optimize AMI, Amazon Machine Image. Now let's look into the correct option. And the correct option is option C. Use Amazon Elastic Container Service, Amazon ECS on AWS Fargate. Now let's look into the next question. Question number 59. A company hosts more than 300 global websites and applications. The company requires a platform to analyze more than 30 TB of Clickstream data each day. What should a solution architect do to transmit and process the clickstream data? And the options are: A. Design an AWS data pipeline to archive the data to an Amazon S3 bucket and run an Amazon EMR cluster with the data to generate analytics. Option B. Create an auto scaling group of Amazon EC2 instances to process the data and send it to an Amazon S3 data lake for Amazon Redshift to use for analysis. Option C. Cache the data to Amazon CloudFront, store the data in an Amazon S3 bucket. When an object is added to the S3 bucket, run an AWS Lambda function to process the data for analysis. Option D. Collect the data from Amazon Kinesis data streams. Use Amazon Kinesis Data Firehose to transmit the data to an Amazon S3 data lake. Load the data in Amazon Redshift for analysis. And the correct option is D. Collect the data from Amazon Kinesis data stream. Use Amazon Kinesis Data Firehose to transmit the data to an Amazon S3 data lake. Load the data into Amazon Redshift for analysis. Okay, so that's the answer for this question. Now let's look into the next question. Question number 60. A company has a website hosted on AWS. The website is behind an ALB, application load balancer, that is configured to handle HTTP and HTTPS separately. The company wants to forward all requests to the website so that the request will use HTTPS. What should a solution architect do to meet this requirement? And the options are: A. Update the ALB's network ACL to accept only HTTPS traffic. Option B. Create a rule that replaces the HTTP in the URL with HTTPS. Option C. Create a listener rule on the ALB to redirect HTTP traffic to HTTPS. Option D. Replace the ALB with the network load balancer configured to use server name identification, SNI. Now let's look into the correct answer, and the correct answer is C. Create a listener rule on the ALB to redirect HTTP traffic to HTTPS. Now, question number 61. It says a company is developing a two-tier web application on AWS. The company's developers have deployed the application on an Amazon EC2 instance that connects directly to a backend Amazon RDS database. The company must not hardcode database credentials in the application. The company must also implement a solution to automatically rotate the database credentials on the regular basis. So basically, the company does not want to save the database credentials in the application. Instead, they want that it should be automatically rotated on a regular basis. So what is the solution which meet these requirements with the least operational overhead? And the options are: A. Store the database credentials in the instance metadata. Use Amazon Event Bridge CloudWatch events rules to run a scheduled AWS Lambda function that updates the RDS credentials and instance metadata at the same time. Option B, store the database credential in a configuration file in an encrypted Amazon S3 bucket. Use Amazon Event Bridge rules to run a scheduled AWS Lambda function that updates the RDS credentials and the credentials in the configuration file at the same time. Use S3 versioning to ensure the ability to fall back to previous values. Option C, store the database credentials as a secret in AWS Secrets Manager. Turn on automatic rotation for the secret. Attach the required permissions to the EC2 role to grant access to the secret. Option D, store the database credentials as encrypted parameters in AWS Systems Manager Parameter Store. Turn on automatic rotation for the encrypted parameters. Attach the required permissions to the EC2 role to grant access to the encrypted parameters. Now let's look into the correct option. Correct option is C, store the database credentials as a secret in the AWS Secrets Manager. Turn on automatic rotation for the secret. Attach the required permissions to the EC2 role to grant access to the secret. Now let's look into question number 62. A company is deploying a new public web application to AWS. The application will run behind an application load balancer. The application needs to be encrypted at the edge with SSL TLS certificate that is issued by an external certificate authority. The certificate must be rotated each year before the certificate expires. What should a solution architect do to meet these requirements? And the options are A. Use AWS Certificate Manager to issue an SSL TLS certificate. Apply the certificate to the ALB. Use the Managed Renewal feature to automatically rotate the certificate. Option B. Use AWS Certificate Manager to issue an SSL/TLS certificate. Import the key material from the certificate. Apply the certificate to the AL. Use the Manage Renewal feature to automatically rotate the certificate. Use AWS Certificate Manager, Private Certificate Authority to issue an SSL TLS certificate from the root CA. Apply the certificate to the ALB. Use the Manage Renewal feature to automatically rotate the certificate. Now let's look into option D. Use AWS Certificate Manager to import an SSL TLS certificate. Apply the certificate to the ALB. Use Amazon Event Bridge, Amazon CloudWatch events to send a notification when the certificate is nearing expiration. Rotate the certificate manually. Now let's look into the correct option. Correct option is option D. Now let's look into question number 63. A company runs its infrastructure on AWS and has a registered base of 7 lakh users for its document management application. The company intends to create a product that converts large .pdf files to .jpeg files. The .pdf files average 5 MB in size. The company needs to store the original files and the converted files. A solution architect might design a scalable solution to accommodate demand that will grow rapidly over time. Which solution meets these requirements most cost effectively? Save the .pdf files to the Amazon S3 bucket. Configure an S3 put event to invoke an AWS Lambda function to convert the files to .jpeg format and store them back in Amazon S3. Option B, save the PDF files to Amazon DynamoD use and the DynamoDB streams feature to invoke an AWS Lambda function to convert the files to .jpeg format and store them back in DynamoDB. Upload the PDF files to an AWS Elastic Beanstalk application that includes Amazon EC2 instances, Amazon Elastic Block storage, and an auto scaling group. Use a program in the EC2 instances to convert the files to JPEG format. Save the .pdf files and the .jpeg files in the EBS store. Option D, upload the .pdf files to an AWS Elastic Beanstalk application that includes Amazon EC2 instances, Amazon Elastic File System storage, and an auto-scaling group. Use a program in the EC2 instances to convert the file to .jpeg format. Save the .pdf files and the .jpeg files in the EBS store. Let's look into the correct option. Correct option is A. Save the .pdf files to Amazon S3. Configure an S3 put event to invoke an AWS Lambda function to convert the files to .jpeg format and store them back in Amazon S3. Now let's look into the next question. Question number 64. A company has more than 5 TB of file data on Windows file servers that run on premises. Users and applications interact with the data each day. The company is moving its Windows workloads to AWS. As the company continues this process, the company requires access to AWS and on premises file storage with minimum latency. The company needs a solution that minimizes operational overhead and requires no significant changes to the existing file access patterns. The company uses an AWS site to site VPN connection for the connectivity to AWS. What should a solution architect do to meet these requirements? Deploy and configure Amazon FSx for Windows file server on AWS. Move the on premises file data to FSx for Windows file server. Reconfigure the workloads to use FSx for Windows file server on AWS. Option B, deploy and configure an Amazon S3 file gateway on premises. Move the on premise file data to the S3 file gateway. Reconfigure the on premises workloads and the cloud workloads to use the S3 file gateway. Deploy and configure an Amazon S3 file gateway on premises. Move the on premises file data to Amazon S3. Reconfigure the workloads to use either Amazon S3 directly or the S3 file gateway depending on each workload location. Option D, deploy and configure Amazon FSx for Windows file server on AWS. Deploy and configure an Amazon FSx file gateway on premises. Move the on premises file data to the FSx file gateway. Configure the cloud workloads to use FSx for Windows file server on AWS. Configure the on premises workloads to use the FSx file gateway. And the correct option is D, deploy and configure Amazon FSx for Windows file server on AWS. Deploy and configure an Amazon FSx file gateway on premises. So basically, deploy and configure FSx Windows file server on AWS as well as on premises. Move the on premises file data to FSx file gateway and then configure the cloud workloads to use FSx Windows file server on AWS. Configure the on premises workloads to use the FSx file gateway. Now let's look into question number 65. A hospital recently deployed an AWS a RESTful API with Amazon API Gateway and AWS Lambda. The hospital uses API Gateway and Lambda to upload reports that are in PDF format and in JPEG format. The hospital needs to modify the Lambda code to identify protected health information in the reports. Which solution will meet these requirements with the least operational overhead? And the options are A, use existing Python libraries to extract the text from the reports and to identify the PHI from the extracted text. Option B, use Amazon Text Extract to extract the text from the reports. Use Amazon SageMaker to identify the PHI from the extracted text. Option C, use Amazon Text Extract to extract the text from the reports. Use Amazon Comprehend Medical to identify the PHI from the extracted text. Option D, use Amazon Recognition to extract the text from the reports. Use Amazon Comprehend Medical to identify the PHI from the extracted text. And the correct option is option C, use Amazon Textract to extract the text from the reports. Use Amazon Comprehend Medical to identify the PHI from the extracted text. Now let's look into the next question, question number 66. A company has an application that generates a large number of files, each approximately 5 MB in size. The files are stored in Amazon S3. Company policy requires the files to be stored for 4 years before they can be deleted. Immediate accessibility is always required as the files contain critical business data that is not easy to reproduce. The files are frequently accessed in the first 30 days of the object creation but are rarely accessed after the first 30 days. Which storage solution is most cost effective? And the options are A, create an S3 bucket lifecycle policy to move files from S3 standard to S3 glacier 30 days from object creation. Delete the files 4 years after object creation. Option B, create an S3 bucket lifecycle policy to move files from S3 standard to S3 one zone infrequent access 30 days from the object creation. Delete the files 4 years after object creation. Option C, create an S3 bucket lifecycle policy to move files from S3 standard to S3 standard infrequent access 30 days from object creation. Delete the files 4 years after object creation. Option D, create an S3 bucket lifecycle policy to move files from S3 standard to S3 standard infrequent access 30 days from object creation. Move the files to S3 glacier 4 years after object creation. Now let's look into the correct answer. And the correct answer is C, which says create an S3 bucket lifecycle policy to move files from S3 standard to S3 standard infrequent access 30 days from object creation. Delete the files 4 years after object creation. Let's look into the next question. Question number 67. But before moving to the next question, I would request you to subscribe to our channel if you are finding this video informative, and it will be helpful in your exam of Solution Architect. So let's continue. Question number 67. A company hosts an application on multiple Amazon EC2 instances. The application processes messages from an Amazon SQS queue, writes to an RDS table, and deletes the messages from the queue. Occasionally, duplicate records are found in the RDS table. The SQS queue does not contain any duplicate messages. What should a solution architect do to ensure messages are being processed only once? And the options are: A. Use the create queue API call to create a new queue. Option B. Use the add permission API call to add appropriate permissions. Option C. Use the receive message API call to set an appropriate wait time. Option D. Use the change message visibility API call to increase the visibility timeout. Now let's look into the correct option, and the correct option is option D. Use the change message visibility API call to increase the visibility timeout. Now let's look into the next question. Question number 68. Solution Architect is designing a new hybrid architecture to extend the company's on premises infrastructure to AWS. The company requires a highly available connection with consistent low latency to an AWS region. The company needs to minimize cost and is willing to accept slower traffic if the primary connection fails. What should the solution architect do to meet these requirements? And the options are: A. Provision an AWS direct connect connection to a region. Provision a VPN connection as a backup if the primary direct connect connection fails. Option B. Provision a VPN tunnel connection to a region for private connectivity. Provision a second VPN tunnel for privately connectivity and as a backup if the primary VPN connection fails. Option C. Provision an AWS direct connect connection to a region. Provision a second direct connect connection to the same region as a backup if the primary direct connect connection fails. And the option D, it says provision an AWS direct connect connection to a region. Use the direct connect failover attribute from the AWS CLI to automatically create a backup connection if the primary direct connect connection fails. And the correct option is A. Provision an AWS direct connect connection to a region. Provision a VPN connection as a backup if the primary direct connect connection fails. Now let's look into the next question. Question number 69. A company is running a business critical web application on Amazon EC2 instances behind an application load balancer. The EC2 instances are in an auto scaling group. The application uses an Amazon Aurora PostgreSQL database that is deployed in a single availability zone. The company wants the application to be highly available with minimum downtime and minimum loss of data. Which solution will meet these requirements with the least operational effort? And the options are: A. Place the EC2 instances in different AWS regions. Use Amazon Route 53 health checks to redirect traffic. Use Aurora PostgreSQL cross-region replication. Option B. Configure the auto-scaling group to use multiple availability zones. Configure the database as multi-AZ. Configure an Amazon RDS proxy instance for the database. Option C. Configure the auto-scaling group to use an availability zone. Generate hourly snapshots of the database. Recover the database from the snapshots in the event of a failure. Option D. Configure the auto-scaling group to use multiple AWS regions. Write the data from the application to Amazon S3. Use S3 event notifications to launch an AWS Lambda function to write the data to the database. And the correct option is option B, which says configure the auto scaling group to use multiple AZs, configure the database as multi AZ, configure an Amazon RDS proxy instance for the database. Now let's look into the next question, question number 70. A company's HTTP application is behind a network load balancer. The NLB's target group is configured to use an Amazon EC2 autoscaling group with multiple EC2 instances that run the web service. The company notices that the NLB is not detecting HTTP errors for the application. These errors require a manual restart of the EC2 instances that run the web service. The company needs to improve the application's availability without writing custom scripts or code. What should a solution architect do to meet these requirements? And the options are: A. Enable HTTP health checks on the NLB, supplying the URL of the company's application. Option B. Add a cron job to the EC2 instances to check the local application's logs once each minute. If HTTP errors are detected, the application will restart. Option C. Replace the NLB with an ALB. Enable HTTP health checks by supplying the URL of the company's application. Configure an auto scaling action to replace unhealthy instances. Option D, create an Amazon CloudWatch alarm that monitors the unhealthy host count metric for the NLB. Configure an auto scaling action to replace unhealthy instances when the alarm is in the alarm state. And the correct option is option C, replace the NLB with ALB, enable HTTP health checks by supplying the URL of the company's application, configure an auto scaling action to replace the unhealthy instances. Now let's look into the next question, question number 71. Now let's look into the next question, question number 71. It says a company runs a shopping application that uses Amazon DynamoDB to store customer information. In case of data corruption, a solution architect needs to design a solution that meets a recovery point objective of 15 minutes and a recovery time objective of 1 hour. What should the solution architect do to recommend? Uh, what should a solution architect recommend to meet these requirements? And the options are A, configure DynamoDB global tables. For RPO recovery, point the application to a different AWS region. Configure DynamoDB point in time recovery. For RPO recovery, restore to the desired point in time. Option C, export the DynamoDB data to Amazon S3 Glacier on a regular basis, on a daily basis. For RPO recovery, import the data from S3 Glacier to DynamoDB. Option D, schedule Amazon Elastic Block Store snapshots for the DynamoDB table every 15 minutes. For RPO recovery, restore the DynamoDB table by using the EBS snapshot. Now let's look into the correct option. Correct option is B, configure DynamoDB point in time recovery. For RPO recovery, restore to the desired point in time. Now let's look into the next question, question number 72. A company runs a photo processing application that needs to frequently upload and download pictures from Amazon S3 buckets that are located in the same AWS region. A solution architect has noticed an increased cost in data transfer fees and needs to implement a solution to reduce these costs. How can the solutions architect meet this requirement? And the options are A, deploy Amazon API gateway into a public subnet and adjust the route table to route 53 calls through to route S3 calls through it. Deploy a NAT gateway into public subnet and attach an endpoint policy that allows access to the S3 buckets. Option C, deploy the application into a public subnet and allow it to route through an internet gateway to access the S3 buckets. Option D, deploy an S3 VPC gateway endpoint into VPC and attach an endpoint policy that allows access to the S3 buckets. And the correct option is D, deploy an S3 VPC gateway endpoint into the VPC and attach an endpoint policy that allows access to the S3 buckets. Now let's look into the next question, question number 73. A company recently launched Linux based application instances on Amazon EC2 in a private subnet and launched a Linux based Bastion host on an Amazon EC2 instance in a public subnet of a VPC. A solution architect needs to connect from the on premises network through the company's internet connection to the Bastion host and to the application servers. The solution architect must make sure that the security groups of all EC2 instances will allow that access. Which combination of steps should the solution architect take to meet these requirements? And you have to select between the two options. And you have to select two options, sorry. And the options are A, replace the current security group of the Bastion host with one that only allows inbound access from the application instances. Option B, replace the current security group of the Bastion host with one that only allows inbound access from the internal IP range for the company. Option C, replace the current security group of the Bastion host with one that only allows inbound access from the external IP range of the company. Option D, replace the current security group of the application instances with one that allows inbound SSH access from only the private IP addresses of the Bastion host. Option E, replace this current security group of the application instances with one that allows inbound SSH access from only the public IP address of the Bastion host. And the correct options are C and D. Replace the current security group of the Bastion host with one that only allows inbound access from the external IP range for the company. Option D, replace the current security group of the application instances with one that allows inbound SSH access from only the private IP address of the Bastion host. Now let's move to the next question, question number 74. A solutions architect is designing a two-tier web application. The application consists of a public-facing web tier hosted on Amazon EC2 in public subnets. The database tier consists of Microsoft SQL Server running on Amazon EC2 in a private subnet. Security is a high priority of the company. How should security groups be configured in this situation? And you have to choose two options. Option A, configure the security group for the web tier to allow inbound traffic on port 443 from 0.0.0/0. Option B, configure the security group for the web tier to allow outbound traffic on port 443 from 0.0.0/0. Option C, configure the security group for the database tier to allow inbound traffic on the port 1433 from the security group for the web tier. Option D, configure the security group for the database tier to allow outbound traffic on ports 443 and 1443 to the security group for the web tier. Option E, configure the security group for the database tier to allow inbound traffic on ports 443 and 1433 from the security group for the web tier. And the correct options are A and C. Now let's look into the next question. Question number 75. A company wants to move a multi-tiered application from on-premises to the AWS cloud to improve the application's performance. The application consists of application tiers that communicate with each other by the way of RESTful services. The transactions are dropped when one tier becomes overloaded. A solution architect must design a solution that resolves these issues and modernizes the application. Which solution meets these requirements and is the most operationally efficient? And the options are A, use Amazon API Gateway and direct transactions to the AWS Lambda functions as the application layer. Use Amazon SQS as a communication layer between the application services. Option B, use Amazon CloudWatch metrics to analyze the application performance history to determine the server's peak utilization during the performance failures. Increase the size of the application server's Amazon EC2 instances to meet the peak requirements. Option C, use Amazon Simple Notification Service to handle the messages between application servers running on Amazon EC2 in an auto scaling group. Use Amazon CloudWatch to monitor the SNS queue length and scale up and down as required. Option D, use Amazon SQS to handle the messaging between application servers running on Amazon EC2 in an auto scaling group. Use Amazon CloudWatch to monitor the SQS queue length and scale up when communication failures are detected. And the correct option is option A, which says use Amazon API Gateway and direct transactions to AWS Lambda functions as the application layer. Use Amazon SQS as the communication layer between the application services. So that's it for today. I hope you enjoyed the video. All the best for your exam, and please don't forget to like, share, and subscribe to our channel. Thank you. Bye bye.